Hi, I am Edward and I'll be your trainer for this course. Getting started with Kubernetes is no easy task, so reach out to me using the Q&A if you're stuck somewhere in this course. Setting up your Kubernetes cluster for the first time can be hard, but once you're past the initial lectures, it will get easier and you will deepen your knowledge by learning all of the details of Kubernetes. When you're finished with this course, you can continue with my 2 other advanced Kubernetes courses. You will get a coupon code in the last lecture, the bonus lecture. This is the course overview of this course. You see, there's a lot to cover. I'll first start with an introduction. What is containers? What is Kubernetes? I will guide you through the setup on your desktop or on the cloud. And then once you have a cluster set up, then we'll start building containers. We'll run the first app on Kubernetes. Then I will explain you the Kubernetes basics. What do you need to know? The node architecture, how to scale, how to use deployments, services, health checks, the lifecycle of the pod, and how to use secrets in your application. I will also show you how to use a web UI. Then we'll start with more advanced topics. I will talk about service discovery, how to use config files, an ingress, which is also a load balancer, external DNS. I will talk about volumes, pod presets, stateful sets, daemon sets, monitoring, auto-scaling, node affinity, and an affinity. I will also cover operators, which can give you extra functionality in Kubernetes. Then I will cover administration. I will talk about the master services, how to set quotas and limits, namespaces, user management, and how to limit your users using RBAC. I'll talk about networking, node maintenance, high availability, and TLS on your load balancer. Then a very interesting topic, packaging. So how do you run your applications on Kubernetes? First, I will introduce you to Helm, and then how to create Helm charts to package your applications. And then we're going to set up a Helm repository to store our Helm charts. And then we will be building and deploying applications using Helm and Jenkins. I have a few extras that you can take. Kubeadm if you want to set up an on-prem cluster, and TLS certificates with a cert manager, which is part of one of my other courses. This allows you to use Let's Encrypt to add certificates to your applications. Course objectives. After this course, you should be able to understand, deploy, and use Kubernetes. You should be able to get started with containerization and run those containers on Kubernetes. To deploy Kubernetes on your desktop, on-prem, and on AWS, to be able to run stateless and stateful applications on Kubernetes, and to be able to administer Kubernetes. You should also be able to package and deploy applications using Helm. And this last one is quite an important one. Let me explain you where you can get support and how you can download the course files. To provide feedback or to get support, you can use the discussion groups, the Q&A. We also have a Facebook group called Learn DevOps Continuously Deliver Better Software. You can scan the following barcode or use the link in the next document after this introduction movie. The next lecture will be a procedure document that you can download. Use the next procedure document in the next lecture to download all the resources for the course. All resources, like demos, are in a GitHub repository. You can clone that GitHub repository, or you can download a zip file on the GitHub website. The URL for this repository is github.com/myaccount/Kubernetes course. I will first start with an introduction. What is Kubernetes? Kubernetes is an open source orchestration system for Docker containers. It lets you schedule containers on a cluster of machines. You can run multiple containers on one machine, and those machines then make up the cluster. You can run long-running services like web applications on your Kubernetes cluster. Kubernetes will manage the state of these containers. You can start a container on a specific node, and Kubernetes will restart a container when it gets killed. It can also move containers from one node to another node. For instance, if you're going to do maintenance on one node, Kubernetes can take all the containers from one node and move them to the other nodes. Instead of just running a few Docker containers on one host manually, because that's what you would do if you wouldn't have Kubernetes, Kubernetes is a platform that will manage the containers for you. Kubernetes clusters can start with one node and can go up to thousands of nodes. Some other popular Docker orchestrators are Docker Swarm, which comes with Docker by default, but isn't as extensive as Kubernetes, and Mesos, which also supports Docker containers, but it was built to run any type of workload. Docker is just one of them. This course will be about Kubernetes, which is in the same category as those two. You can run Kubernetes anywhere. On-premise, in your own data center, public, on the Google Cloud, on AWS, maybe on other clouds, or in a hybrid way. You can run it public and private. Some of your workloads you might want to keep on-premise, so you might run them privately, and other workloads you might run them on the public cloud. So you can have the same system, the same abstraction on the public cloud as on private, which is very powerful. It is highly modular, so you can make changes if necessary. It is open source. The project is on GitHub. You can easily make changes, and they encourage everyone who wants to join the community. You can make changes, which makes it a great community, and it's also backed by Google. So when they did the original release, it was actually written by Google employees, and they are still supporting it. So it's backed by Google, and it incorporates all the good stuff that Google already does for decades. Google already runs containerized applications for more than 10 years, using their own system, Borg it's called, and now they incorporated those ideas in Kubernetes that they then released to the community. Now that I gave you an introduction to Kubernetes, let me just talk a little bit about containers in general. If you already are familiar with containers, you can just skip this lecture and continue with the next one. So let's first talk a little bit about the difference between a virtual machine and a container. On the left here, you see what a virtual machine is. You have a server, the physical machine, then on that physical machine you put a host OS, here in green. Then you have the hypervisor, which is going to manage the guest OS operating systems for you. So you can have multiple guest operating systems on one host operating system using this hypervisor. Every guest operation is completely isolated. It has its own binaries, its own libraries. It can run applications. It is pretty heavy. Like a full virtual machine is a full operating system with the binaries, the libraries, and the application bundled. And it also takes some time to boot up. It needs to go through the whole boot cycle, which can take minutes before your guest operating system is live. So that brings us to containers. So here on the right, you see what a container is. You have still the physical server, then you have a host operating system, and then you can have multiple containers on your host operating system using the Docker engine. Docker is just one example of software that is available. There is other software available for containers as well. Here we have 3 containers. The containers contain binaries and libraries with applications in them. They don't need to boot up the full guest operating system. So when you launch a container, instead of waiting minutes, it will almost instantly start your container. So it's a lot more lightweight than the virtual machines. Containers can also be a couple of megabytes, where virtual machines are often a lot bigger. Then containers on cloud providers are still a little bit different than just running a container on a host operating system, because cloud providers still use this hypervisor to isolate the customers from each other. So you still have a server, a host operating system, hypervisor, then you have a guest operating system, and on top of that you have containers. Currently that's just how it is, but you will still get all the benefits of containerization even on cloud. You just have this extra abstraction layer between your containers and the host operating system. On cloud providers, you're typically also going to have multiple guest operating systems running then multiple containers, and those nodes together will then form your cluster where you're going to run containers on. Docker is the most popular container software. There are alternatives available. An alternative to Docker is Rocket, which also works with Kubernetes. If you don't want to use Docker, you can use Rocket instead. Docker consists of Docker Engine. It's a Docker runtime. It's a software to make run the Docker images. and also the software that you will use to build those Docker images to then run on your Kubernetes cluster. You also have Docker Hub, which is an online service to store and fetch Docker images. So once you build an image with Docker Engine, you can then store it on the internet using Docker Hub. You have public repositories and you have private repositories where you can store your Docker images. Docker Hub also allows you to build those Docker images online. So they provide a service to you that you don't have to build them on your PC. You can also build them online. The cloud providers itself also have alternatives to Docker Hub. For instance, AWS has its own repository where you can save your Docker images. You can also run your own Docker Hub. You could run your own repository if you would like to. So what are the benefits of Docker? You have isolation. You ship a binary with all the dependencies. No more, it works on my machine, but not in production. It's the same binary that you use on your machine to test your software that you will be then using in production. So there is a closer parity between dev, QA, and production environments because you are using the same binary. Docker makes development teams able to ship faster. We can build images pretty quick. You can then distribute them pretty easily using Docker Hub or another registry, and then your servers can start pulling those images. This would be a lot more cumbersome with virtual machine images than with container images. You can run the same Docker image unchanged on laptops, data center VMs, and cloud providers. So you can have the same image that you run on-premise and in the cloud, and it should act exactly the same. Docker uses Linux containers, which is a kernel feature for operating system level isolation. The reason why containers cannot go to the host system or to other containers, or you don't see information of other containers, is because of this isolation done on a kernel level. If you have read already something about containers, you probably have seen this analogy already. It's a ship with containers on. So basically with containerization, you just build your container, and in that exactly same state, you can run it wherever you want. The container contains all the dependencies, so it should execute exactly the same, whether you run it locally, in the cloud, on Kubernetes, or anywhere you want to run it. And that is the main advantage of using containers. In this lecture, I'll be talking about the Kubernetes setup. I'll first talk about the different ways of setting up Kubernetes. Then I will show you how to set it up locally and on AWS. Kubernetes should really be able to run anywhere, but there are more integrations for certain cloud providers like AWS and Google Cloud. Things like volumes and external load balancers work only with supported cloud platforms. So if the integration for your cloud platform is not available, then you can still use Kubernetes, but you will not be able to use volumes and external load balancers. For AWS and Google Cloud, this is available. Also for Azure, this is available. So for the main providers, this is already available. Other providers have different types of support. You'll have to take a look in the documentation at the cloud provider plugins to see which ones are supported. I will first use Minikube to quickly spin up a local single machine with a Kubernetes cluster. You can use Minikube on your laptop or your desktop to spin up a Kubernetes cluster. I will then show you how to spin up a cluster on Amazon AWS using Kops. Kops is a tool that can be used to spin up a highly available production cluster. Doing the labs yourself is possible and highly recommended. Using the AWS free tier, which gives you 750 hours of T2 micros per month. So it's not just one T2 micro, it's 750 hours per month. So you can run multiple T2 micros as long as you don't exceed this number of 750 hours per month. The URL to sign up is awsamazon.com. You can do the same labs using your local machine. You will not be able to test the integrations with the cloud, but you can still use Kubernetes. You can use Minikube from this URL. You can find these URLs as well in the procedure document in the beginning of the course. Or if you want, you can use DigitalOcean and you can use this URL to get a $10 coupon. Let's set up Kubernetes locally using Minikube. Minikube is a tool that makes it easy to run Kubernetes locally. Minikube runs a single node Kubernetes cluster inside a Linux VM. It's aimed on users who want to just test it out or use it for development. It cannot spin up a production cluster. It's a one-node machine with no high availability. Now the good news, it works on Windows, Linux and macOS, so you can use it on your PC whatever you are running. You will need virtualization software installed to run Minikube. For instance, you can use VirtualBox, which is free and can be downloaded from virtualbox.org. You can download Minikube from this URL. You can just copy paste it from the procedure document, or you can just type it over from this video. To launch your cluster, you just need to enter in a shell in Linux, in a terminal on macOS, or in PowerShell or CMD in Windows. Minikube start. If you're using Windows, you first have to cd into the directory where you downloaded Minikube, and then you can start Minikube with this Minikube start command. I will just show you that in a demo in the next lecture. In this demo, I will show you how to do a local Kubernetes setup using Minikube. This is the Kubernetes Minikube GitHub URL. You will find all the GitHub releases under releases right here. So here you can download manually the latest release of Minikube. They have versions for macOS, for Windows and for Linux. The easiest way is to use a package manager. So if you go back to the Minikube main URL, then below you have README, and in this README you're going to find a getting started guide. Using this getting started guide, you can install Minikube for Linux, macOS or Windows. And I would recommend you to follow this guide to install Minikube on your system, because the guide splits out different options, and depending on what OS and version of your OS you're running, you might have to go with a different option. So I'm going to show you this demo on macOS, and on macOS it's pretty straightforward, but if you're on Windows, I will just follow this guide to get it installed. So let's quickly go over the different options. Let's say that you're on Linux. You can just download and install Minikube in user local bin using this command. You would still have to install the command line utility kubectl, which you can download from the Kubernetes website. In my procedure document, you will find the URLs that you can use to download kubectl. So this is for Linux. Then for macOS, you have two options. You can use brew, which is the easiest way. It will automatically install the kubectl command line utility for you, or you can use direct, also using the curl command, and extract it in user local bin Minikube. And then you have the Windows option, and with Windows you can download the Minikube installer, which will install it for you, or you can use a package manager, the Chocolatey package manager. If you don't have this yet, you can download this package manager from here and then run this command, and this will install Minikube for you. So the difficulty that will arise is that Minikube will start a VM to run Kubernetes in. So you cannot, and that is important, you cannot run Minikube within a VM. It will spin up a VM itself. That means that you will have to choose a hypervisor. So you on Windows and also on Mac, you have different hypervisors. So on Windows, you can either use Hyper-V or VirtualBox. And then using these commands here, you can see which hypervisor is installed on your system. So if you have a look here, for example, Hyper-V will only work on Windows 10 Enterprise, Pro or Education. If you have the Home Edition, you will not be able to use Hyper-V, you should use VirtualBox. So then you download VirtualBox and then you use Minikube start VM driver VirtualBox. And using this command, you can make it a default driver. So in general, Home Edition, VirtualBox, otherwise you can use Hyper-V, and with Hyper-V, you still might have to enable it as an administrator. So whether you will be able to run Minikube all depends on the hypervisor. If you have troubles launching Minikube, it will probably be a hypervisor issue. There are alternatives. You can use, for example, Docker for Windows, Docker for Mac, if you have issues starting Minikube. I would still recommend to try Minikube first because it's such an easy way to get Kubernetes running on your system. So to summarize, getting started guide right here to install Minikube. And then if you're not using a package manager, download kubectl, install and set up kubectl for Linux or for Mac or for Windows. So for example, if you're on Windows, you can download the latest version from this link. I also have in my procedure document links to the kubectl version. If you already have Docker for Windows installed, then this will also have a kubectl version. Probably best to just type kubectl already in a PowerShell or a CMD on Windows to see if you have kubectl available. Make sure that if you download the latest version of Minikube, that you also have a new version of kubectl, which means if you already have a kubectl installed, you probably want to upgrade that one. Otherwise, you can get some errors when you're trying to connect to your cluster. So let's try to set Minikube up on my machine. So I will just use brew because that's the easiest. Brew install Minikube. So if you are on macOS, it's going to be pretty easy to install Minikube. It will also install the kubectl for me. So I will have Minikube and the kubectl. Once this is done, and this command is exactly the same whether you are on Windows, Mac or Linux, you run Minikube start. And if you are on Windows, you might have to add the VM driver here. If you don't add the VM driver, it's going to automatically select one for you. So here it says automatically selected the HyperKit driver and alternatives is VirtualBox. So for me, it's going to use a HyperKit, but I could also use VirtualBox. HyperKit is preferred over VirtualBox on Mac. So this is then going to set up HyperKit. So I need to give my root password of the machine. And then it's going to download the latest VM image. Now it's creating a new VM, and that's why we cannot run Minikube within our own VM. We need to run it on our host system. So if your host system is Windows, then you need to run it on your Windows machine because it will create a VM, a virtual machine itself. So all our Kubernetes processes will run in this VM that Minikube is creating. So now it is preparing Kubernetes 1.17.0 on Docker 19.035. So because we are using Kubernetes 1.17, you also want to make sure that your kubectl version is also on 1.17. So if I just open another window, kubectl version, and I can also see that my kubectl is version 1.17, 1.17.0. So this one will definitely be compatible with the Kubernetes that I'm running within Minikube. So then once it starts, the VM is going to use Kubeadm to set up my cluster. I also have at the end of this course some Kubeadm lectures where we use Kubeadm manually to set up Kubernetes on a couple of VMs within the cloud. So if you want to do it completely manual on a virtual machine, you can use Kubeadm for that. Then it's pulling the images, launching Kubernetes, waiting for the cluster to come online, and now it is done. Minikube also says that it has configured kubectl to use Minikube. So that basically means that it created a config for us. Where is this config? It is in our home directory in .kube config. So Minikube set this up for us. It set up the certificate, the server. So now we can connect to this server using kubectl to execute Kubernetes commands. So let's have a look again at the documentation, which has some example commands that we can run to test whether our cluster is running. So here we have the link examples, Minikube start that we did. If you want, you can run a Minikube dashboard to see a dashboard. We're going to skip that for now. I have some lectures later on the dashboard. And then you can do kubectl create deployment, hello Minikube, which is going to create a deployment using the echo server image. It's just a test image to see whether it's working. And then we're going to expose the service as a node port. I will explain to you later on what node ports means. Now we're just going to copy paste these commands, see whether our cluster is working, and then later on I will explain in depth what this all means. kubectl create deployment, hello Minikube. Deployment is created. So now it created a service so that I can reach my hello Minikube deployment. And because this is now all created in a Kubernetes within the cluster, I now also need to enter a command to know the IP address and the port where I can connect on to reach this service. So Minikube service hello Minikube. And this went pretty quick, but it actually opened a browser window and it immediately went to the correct URL. So let's have another look at the terminal first. So we have the namespace, default namespace, name hello Minikube, and then the URL that we have. So this is the node port that has been opened on this IP address of my virtual machine. So you see here server 192.168.64.8 on port 8443, which is a Kubernetes API server. Now it created another port. It opened another port, the node port where then my service is reachable on. So then it says opening service default hello Minikube in a default browser. Then it opens within my browser this URL. And this is exactly what the echo server is returning. The echo server just returns some information about the request. So we have the client values, server values, and the headers received. There was nobody in the request. When you are finished with a lab and you want to stop Minikube, you can just run Minikube stop, and this will then stop the Minikube VM. If you did something wrong and you want to completely destroy your VM, you can use Minikube delete, and this will then delete the VM completely. And then when you then do Minikube start, it will start a new VM. You don't have to delete it all the time, only when something major went wrong and you cannot recover, or you completely finish with Minikube, you want to make sure that you don't have the VM installed anymore. Then you can use Minikube delete to delete the cluster and delete the profile from your kube config. So that's it for Minikube. Minikube is a very powerful tool that you can use to test with Kubernetes and deploy on Kubernetes using your local machine. It might be a bit tricky to set up for the first time, especially on Windows, but once it is set up, it is pretty easy to use. Minikube is really a great tool to install and use Kubernetes, but sometimes it doesn't spin up, sometimes it doesn't work with your configuration, with your desktop. So there is an alternative. You can download Docker, and the newest versions of Docker allow you to install Kubernetes within the client. So that makes it a lot easier to use Kubernetes if you're already using the Docker client or if Minikube doesn't work for you. So in this demo, I will show you how this works. So if you just type in Docker client Windows Edge in Google, then you will get on this page. storedocker.com, editions, community, it's a community edition. Docker, CE stands for community edition, desktop Windows. And here on this page, you can download the stable version or the Edge version. Because Kubernetes within the Docker client is pretty new, you need the Edge version. At some point, they will include it in the stable version, but now you need the Edge version. So you need to download the Edge version for Windows, or you can download the Edge version for Mac. So I downloaded the Edge version for Mac. It's an installer and it will install Docker in your tray in Mac, but I suppose in Windows it's exactly the same. And once it's started, it starts by default when you start it. Then you can go to Preferences. And when you open your Preferences, a window like this will open and you should have an icon here, Kubernetes. If you don't have this, then you're probably on the stable version and you should download the Edge version. To enable Kubernetes, you just click on this, you click on Kubernetes and you press Apply. Kubernetes is now starting. This can take a few minutes. So my Kubernetes cluster is now running. This is the macOS terminal that I launched. If you are on Windows, you can just launch the command cmd or a PowerShell to get a terminal. And then you will also be able to use the docker and kubectl commands. So I can now use a terminal and do kubectl get nodes. And I get my docker for desktop. If you already tried to use Minikube earlier before that, you might have to change your context. So kubectl config get context will show you the context that you have. And now I only have one cluster, one context, but if you're using Minikube, it's possible that there's also a Minikube context here. And then you just have to use kubectl config use context, and then the name of the context will switch you to that cluster. We switched now, but I was already on this context. So this is only if you have multiple contexts. If you used Minikube earlier, or you already had a cluster installed earlier. Now I can start using it. kubectl get nodes. I have one node. Let's try to run a pod. I will run kubectl run hello Kubernetes, and I'm going to use the echo server, port 8080. Deployment hello Kubernetes created. kubectl expose deployment hello Kubernetes type node port. I'm creating a service so that I can access this hello Kubernetes. So this is just a test. I will explain you in the coming lectures what it all means. Just to see whether the cluster is working, I should now be able to connect to this service. Get service hello Kubernetes. And I should now be able to go to my browser on localhost, and this port I should be able to connect. Localhost and this port, and this just gives me a response. So this is my request URI localhost 8080. That's what my pod is running on. So if you get this, then your Kubernetes install is properly working, and you just created your first application, your first pod on Kubernetes. So in the next lectures, I will go in a bit more detail what all these things mean. This is definitely a good alternative to Minikube if you don't get Minikube running, or you just want to use only the Docker client with Kubernetes, and then you only have to install one package. I just showed you how to use Minikube or the Docker client to get a Kubernetes cluster. Now let's talk a little bit about other tools to run a production cluster. There are multiple tools to install a Kubernetes cluster. I showed you how to use Minikube and the Docker client. Those are for local installs. If you want a production cluster, you will need different tooling. Minikube and Docker client are great for local setups, but not for real clusters. They spin up only a one-node cluster for development and testing. Kops and Kubeadm are tools to spin up a production cluster. You don't need both tools, just one of them. On AWS, the best tool is Kops. At some point, AWS EKS, the hosted Kubernetes, will also be available. At that point, this will probably be the preferred option. With a hosted solution, you don't need to maintain the masters. With Kops, you own all the infrastructure, so you also need to maintain the masters. For other installs, or if you cannot get Kops to work, you can use Kubeadm. Kubeadm is an alternative approach, and Kops is still recommended on AWS. You also have AWS integrations with Kops automatically. Kubeadm is a more generic tool, so it's an alternative approach if you're not on AWS or if you cannot get it working, but I still recommend you to use Kops if you are on AWS because you will get the integrations with IAM and the load balancer and so on. The Kubeadm lectures can be found at the end of this course and let you spin up a cluster on DigitalOcean. Because the focus on this course is really on Minikube and Kops, I just put the lectures at the end because they provide you an alternative way of setting up a cluster. If you have AWS, you should always try AWS first. If you're going to do bare metal or another cloud provider, then Kubeadm can be a good alternative. So you can go to github.com/kubernetes/kops. Here, there is download the latest release, and you can download the Kops Linux AMD 64. Copy link address, and then I can download this Kops Linux AMD 64 to this machine. This is downloaded. I can do chmod Kops Linux AMD 64 plus executable flag so that I can execute it. and I can move this to user local bin. I have to do a sudo, and then I'm going to download Python pip, because Python pip will allow me to install AWS, the AWS command line utility, which I will also need before I can set up this cluster on AWS. So this is installed, so I should be able to do pip install AWS command line utility. And this is going to give me the command line utility called AWS that I will then be able to use. So if I now type AWS, I can now execute commands on AWS. If you don't have an AWS account yet, you have to open one. AWS, Amazon.com, create an AWS account. And when you create a new account, you will automatically get the free tier. Once you create a new AWS account, you will see this screen, the AWS Management Console. You can go to Services and then go to IAM to manage access to AWS resources. On the left, you can click Users and then Add User to add a new user that will be used by us to configure so that Kops can access our AWS account. Username can be Kops, but can be really anything that you want. And we're going to select programmatic access so that we get an access key ID and secret key that we then can configure using the AWS command line utility. Now we can add this user to a group. So for example, you can create a new group administrator or attach existing permissions. Probably the easiest is to add existing permissions. This is administrator access that you can then give this user. You can also choose to create an admin group and then give that group administrator access and assign that group to this user. And that you can do in the first tab, add user to group. Here we are just attaching the policy directly. We're not going to add text at this point, and then we can review our user. So username is going to be Kops for programmatic access, and it's going to have administrator access. We can create this user. This user was successfully created. So now we have the AWS access key ID, and then when you click here on show, then it will show the secret access key, which we need to configure the AWS command line utility. Those we need to copy paste. We're going to the shell of our VM where we installed AWS, the command line utility, and we're going to type AWS configure. It asks for the AWS access key and for the AWS secret access key. Both were printed when you were creating this user. You can specify a default region or an output format, but that's not necessary. So that's it. Now, what the AWS utility did, it actually created these files in .aws, and our credentials are now configured, so we can now use AWS. Next, I'm going to go back to the welcome screen, and I'm going to go to S3. S3 is an object storage. You can compare it with Google Drive or a Dropbox. And we're going to create a new bucket. And this bucket is going to be used for our Kops state. And I'm just going to add some random string at the end, which you also should do, and you also should make it random, because this bucket name needs to be unique in Amazon in that region. This region that you specify here is going to be the region where you want to deploy your cluster. So if you want to deploy a cluster in Ireland, you should choose the Ireland region. So depending on where you are, you can choose a different bucket. If you don't know what region to choose, there's a tool, cloudping.info. You do an HTTP ping, and for me, Europe and Frankfurt are the closest ones. I'm going to go with Ireland. You are going to do this from a different location, so you're going to see different results. I'm going to choose Ireland. I'm going to click create, and now I have my Kops bucket. Next is the DNS. So Kops is also going to set up DNS for us, but we need to set up a domain for that, a subdomain. So you can use root 53 for that. Route 53 allows you to do DNS management. Kops expect you to enter a subdomain, and Kops will manage that subdomain for you. But you already need to create this zone in Route 53 so that Kops can manage this for you. You can either register a new domain name here on Amazon or even somewhere cheap where you can get one for a couple of bucks. There are also free solutions, so you don't need to spend money for a domain name. There is a .tk, and there's also providers that give you subdomains that you then can use in Route 53. So you don't need to spend money if you don't want. If you don't have a domain name, it's probably the easiest way to just go for something free. Have a look at the procedure document. I listed some free solutions there. I have my own domain name, so I'm going to get started here with DNS management. I'm going to create a hosted zone. So even if you have your own domain name, or if you opt for one of the free solutions, you still need to create this hosted zone. And this is actually going to cost you some money. Right now, this costs you $0.50 per month to create a hosted zone. So if you don't want to spend any money at all, you might just want to run Minikube. Maybe Kops is not the solution for you. So I'm going to click Create Hosted Zone, and I'm going to use kubernetes.newtech.academy. I have the domain name newtech.academy. So what I will do is I will make sure that Kubernetes Newtech Academy is going to forward to Route 53. And to make it forward, I need to specify these values here, and those are going to be different for you, as name servers for this subdomain. My domain is hosted at Namecheap, so I'll have to go to Namecheap, tell Namecheap Kubernetes.newtech.academy is hosted by Route 53. These are the name servers. And you will easily find that if you buy a domain name. It's quite straightforward to make those changes. Just to show you how it works with Namecheap, you have something called Advanced DNS, and here I added 4 new records for Kubernetes for this domain name, so that I have a subdomain kubernetes.newtech.academy, and they point to the Route 53 name servers. So I did add new record, and as record, Kubernetes as a host, and then whatever name server that you will see. So if you do this yourself, don't take these name servers, but take the ones that you see when you add a hosted record in Amazon. If you use something else than Namecheap, for instance, a free .tk domain name, then this will look a little bit different, but it's the same principle. You will have to add an NS record for a domain or a subdomain to be able to make this work. Once we set up the DNS, Kops is going to manage the DNS for us using Route 53. So now we have done all the preparation and we can finally start launching our cluster using Kops. And that I will show you in the next demo. In this demo, I will show you the setup of Kubernetes with Kops. You can use Kops on Linux and on Mac. If you have Windows, you first have to install Vagrant and VirtualBox. So what I will first show you is to just start a new VM with VirtualBox. You can do that on Mac, on Linux, and on Windows as well. So first you download Vagrant up and VirtualBox, then you install it. It's very easy, very straightforward. Then you open a shell or a terminal on Mac, and then you create a directory. In this directory, you do Vagrant init and the Ubuntu box that you want. I'm going to use Ubuntu Xenil64, but you can use any Linux distribution that you want. On the website of Vagrant, you can find other boxes if you would rather run another operating system. This Vagrant init will create a Vagrant file, and then you just do Vagrant up. Vagrant up is then going to use VirtualBox to set up this Ubuntu Xenil64 box. This might take some time, a couple of minutes. And then this is what you should see when it is set up. You also see that within the Linux box you just created, you have a /vagrant that is pointing to the current directory that you are in on your host system. To log in vagrant ssh-config, Linux and Mac users will just be able to do vagrant ssh. Windows users need to take a look at this identity file here. This is going to point to a path of the private key that they can use in PuTTY. So PuTTY is a tool for Windows to log in into SSH, and you can use PuTTY and PuTTY to first convert this private key using PuTTY and then log in with PuTTY to this box. You can also use Vagrant SSH, but then you need to install the OpenSSH client. So whatever you think is most easy for you, you can do. Either you use PuTTY and PuTTY to log in with your private key. The login is Ubuntu, or you install these OpenSSH libraries. If you would be stuck, there's lots of information on the internet on how to convert a key using PuTTY and PuTTY. There's lots of screenshots. So have a look there. If it still doesn't work, just use a Q&A and tell me exactly where you're stuck, and I will try to help you. So from now on, I'll assume that you have a Linux box available on whatever platform that you are. So from this point on, I'll be using the Linux downloads, and I will be using this box to set up the Kubernetes cluster. So the next step here is that we're going to download Kops so that we can install Kubernetes. So you can go to github.com/kubernetes/kops. Here there is download the latest release, and you can download the Kops Linux AMD 64. Copy link address, and then I can download this Kops Linux AMD 64 to this machine. This is downloaded. I can do chmod Kops Linux AMD 64 plus executable flag so that I can execute it, and I can move this to user local bin. I have to do a sudo, and then I'm going to download Python pip, because Python pip will allow me to install AWS, the AWS command line utility, which I will also need before I can set up this cluster on AWS. So this is installed, so I should be able to do pip install AWS command line utility. And this is going to give me the command line utility called AWS that I will then be able to use. So if I now type AWS, I can now execute commands on AWS. If you don't have an AWS account yet, you have to open one. AWS, Amazon.com, create an AWS account, and when you create a new account, you will automatically get the free tier. Once you create a new AWS account, you will see this screen, the AWS Management Console. You can go to Services and then go to IAM to manage access to AWS resources. On the left, you can click Users and then Add User to add a new user that will be used by us to configure so that Kops can access our AWS account. Username can be Kops, but can be really anything that you want. And we're going to select programmatic access so that we get an access key ID and secret key that we then can configure using the AWS command line utility. Now we can add this user to a group. So for example, you can create a new group administrator or attach existing permissions. Probably the easiest is to add existing permissions. This is administrator access that you can then give this user. You can also choose to create an admin group and then give that group administrator access and assign that group to this user. And that you can do in the first tab, add user to group. Here we are just attaching the policy directly. We're not going to add text at this point, and then we can review our user. So username is going to be Kops for programmatic access, and it's going to have administrator access. We can create this user. This user was successfully created. So now we have the AWS access key ID, and then when you click here on show, then it will show the secret access key, which we need to configure the AWS command line utility. Those we need to copy paste. We're going to the shell of our VM where we installed AWS, the command line utility, and we're going to type AWS configure. it asks for the AWS access key and for the AWS secret access key. Both were printed when you were creating this user. You can specify a default region or an output format, but that's not necessary. So that's it. Now, what the AWS utility did, it actually created these files in .aws, and our credentials are now configured, so we can now use AWS. Next, I'm going to go back to the welcome screen, and I'm going to go to S3. S3 is an object storage. You can compare it with Google Drive or a Dropbox. And we're going to create a new bucket. And this bucket is going to be used for our Kops state. And I'm just going to add some random string at the end, which you also should do, and you also should make it random, because this bucket name needs to be unique in Amazon in that region. This region that you specify here is going to be the region where you want to deploy your cluster. So if you want to deploy a cluster in Ireland, you should choose the Ireland region. So depending on where you are, you can choose a different bucket. If you don't know what region to choose, there's a tool, cloudping.info. You do an HTTP ping, and for me, Europe and Frankfurt are the closest ones. I'm going to go with Ireland. You are going to do this from a different location, so you're going to see different results. I'm going to choose Ireland. I'm going to click create, and now I have my Kops bucket. Next is the DNS. So Kops is also going to set up DNS for us, but we need to set up a domain for that, a subdomain. So you can use route 53 for that. Route 53 allows you to do DNS management. Kops expect you to enter a subdomain, and Kops will manage that subdomain for you. But you already need to create this zone in Route 53 so that Kops can manage this for you. You can either register a new domain name here on Amazon or even somewhere cheap where you can get one for a couple of bucks. There are also free solutions, so you don't need to spend money for a domain name. There is a .tk, and there's also providers that give you subdomains that you then can use in Route 53. So you don't need to spend money if you don't want. If you don't have a domain name, it's probably the easiest way to just go for something free. Have a look at the procedure document. I listed some free solutions there. I have my own domain name, so I'm going to get started here with DNS management. I'm going to create a hosted zone. So even if you have your own domain name, or if you opt for one of the free solutions, you still need to create this hosted zone. And this is actually going to cost you some money. Right now, this costs you $0.50 per month to create a hosted zone. So if you don't want to spend any money at all, you might just want to run Minikube. Maybe Kops is not the solution for you. So I'm going to click create hosted zone, and I'm going to use kubernetes.newtech.academy. I have the domain name newtech.academy. So what I will do is I will make sure that Kubernetes Newtech Academy is going to forward to Route 53. And to make it forward, I need to specify these values here, and those are going to be different for you, as name servers for this subdomain. My domain is hosted at Namecheap, so I'll have to go to Namecheap, tell Namecheap Kubernetes.newtech.academy is hosted by Route 53. These are the name servers. And you will easily find that if you buy a domain name. It's quite straightforward to make those changes. Just to show you how it works with Namecheap, you have something called Advanced DNS, and here I added 4 new records for Kubernetes for this domain name, so that I have a subdomain kubernetes.newtech.academy, and they point to the Route 53 name servers. So I did add new record, and as record, Kubernetes as a host, and then whatever name server that you will see. So if you do this yourself, don't take these name servers, but take the ones that you see when you add a hosted record in Amazon. If you use something else than Namecheap, for instance, a free .tk domain name, then this will look a little bit different, but it's the same principle. You will have to add an NS record for a domain or a subdomain to be able to make this work. Once we set up the DNS, Kops is going to manage the DNS for us using Route 53. So now we have done all the preparation and we can finally start launching our cluster using Kops. And that I will show you in the next demo. This lecture is completely optional. If you didn't have any issues with DNS, then you can skip this lecture, or you can come back to it later on if you realize that at some point your cluster doesn't work because you have an issue with DNS. In this demo, I will show you a little bit about DNS troubleshooting. Kops need to have DNS working properly, otherwise you cannot start your cluster, or you can sometimes start your cluster but not connect to it. So here in this lecture, I will talk a little bit about DNS troubleshooting. On the machine that you are using Kops, a Linux machine, you can use the program host. You first need to make sure that host is installed. So you can use sudo apt install byte9 host. In my case, it's already installed. So now we can use the executable host. To make sure that the name servers are properly set, you can do host -t ns. NS stands for name server of, in my case, Kubernetes New Tech Academy. You can see that the name servers of this name, Kubernetes New Tech Academy, point to the Route 53 zone. If this doesn't return the Amazon name service of your Route 53, then something is not working. In Route 53, you also need to make sure that the reply of the name servers also matches exactly this. So these are specific name servers for this zone. You cannot use my name service because yours will be different. The reason why this resolving works, this host -tns, is because I put these records in place in the DNS control panel of Namecheap. Let's say that you don't use Namecheap and that you only use AWS Route 53. Well, then you need to create a hosted zone. For example, I will create a hosted zone for New Tech Academy. And I will click create. And this New Tech Academy has different name servers. And still, if I go back to my terminal, even though I created this public host name, if I do host tns of New Tech Academy, it will still point to registerservers.com, which is Namecheap, because Namecheap is still responsible for the name servers. So if I do wish, which is not a tool of this domain name, I can see that the name servers are set on this register. So if you want to host your full domain name on Amazon, which is not necessary, but if you want, then you need to change the name servers in Namecheap, not in the DNS management, but there's also an option name servers, and every domain provider has that option where you can change the name servers, and then you have to point the name servers to these name servers. Then your domain name points to this hosted zone, but that doesn't mean that this hosted zone will work automatically. Then you have to still create name server records that point from your main domain name, New Tech Academy, to Kubernetes New Tech Academy. So then you can copy those, go to New Tech Academy, and then create a record set. And then this is going to be Kubernetes New Tech Academy, and the value will be these name servers. And this is going to be an NS record. And then you're going to have Kubernetes New Tech Academy is going to point to your other Route 53 zone. So this is only necessary if you want to host your main domain as well on Amazon, because then you need to make sure that you register, your domain register uses these records because these are from your main domain, and that you add also here, just like I did in the previous lecture, records and S records to point to Kubernetes New Tech Academy. The third option is that you don't use Kubernetes New Tech Academy, you don't use a subdomain, but you just pass this main domain name as a cluster name and as a DNS name. And then you will have, and then you don't have Kubernetes New Tech Academy, so you can remove this record. Then you only need this, and then you use your main domain name as a cluster name and as a DNS name. And then you will have api.newtechacademy instead of api.kubernetes.newtechacademy. So that's the third option that you can use. The best option is to use, like I explained in the previous lecture, you often have a DNS management at your domain register, and then you can just add this NS record. If that's not possible, you can create a second hosted zone for your main domain name, and then you can also add an NS record to Kubernetes New Tech Academy. So that all works. So then at the end, when you do all this configuration, then you need to check whether host NS New Tech Academy resolves to the correct one, and Kubernetes New Tech Academy resolves to the correct root 53 zone. So in my case, it first goes to my register, and my register I have a DNS record set that points to my hosted zone, my root 53 hosted zone. So I hope this makes it a little bit more clear. DNS is not an easy topic. You might have to spend some time to set this up. Also, when you set this up, it might take another 30 minutes, 1 hour before those changes are propagated. So these records might be cached sometimes. So sometimes you just have to wait half an hour, 1 hour before you get the correct results. At this point, you should have set up your Vagrant box. You should have set up AWS. So now we can launch our Kubernetes cluster using Kops. Here I'm logged in to my Ubuntu Xenial box. Before setting up the cluster, you need to make sure that you have kubectl installed as well. This URL you can find in the procedure document. You can just download it. You move it to user local bin, exactly where Kops is as well, and you give it execution permissions. And then when you type kubectl, you have kubectl available. Before creating the cluster, you will also have to create new SSH keys, and those SSH keys will be used to log in to the cluster. SSH keygen can create new keys. So what I'm going to do is I'm going to create a new key in .ssh id RSA. And this public key, id RSA pub, will be uploaded to our instances. And that way we will be able to log in to our instances using our private key. So id RSA is our private key. This is our public key. Public key goes on the instance and we log in with the private key. And just one thing I want to do before I'm going to enter the Kops command is I'm just going to rename the Kops binary. I'm going to rename it in just Kops rather than having Kops Linux AMD 64. This is the Kops command I'm going to execute, and this Kops command is not going to do anything yet because it needs another step before it's really going to execute the commands on AWS. But this one is going to create one master, a T2 micro, and 2 nodes, also T2 macro. So we have Kops create cluster, we give it a name. This needs to be the full DNS name of the cluster. I have Kubernetes New Tech Academy, the one that I set up in root 53. I'm going to save the state in S3. This is my S3 bucket. And I'm going to launch it in the EU West 1A zone. You're probably going to use another zone. US East 1A, US West 1A, and so on. Node count is 2, and the node size is T2 micro. The master size is also T2 micro, and the DNS zone is Kubernetes New Tech Academy. I'm going to execute this, and then you will be able to preview the changes that will be made to AWS. So it's going to make auto-scaling groups for our nodes. It's going to launch a master. It's going to provision also SSD drives. And then if we want to really launch this cluster, then we can just do this with Kops update cluster and then the name with -- yes. And then it's going to launch. If you want to make changes first, you can edit the cluster using Kops edit cluster and then the name. But because the state is on S3, you also have to specify the state. So then the command will work and then you can still make some changes. I'm not going to make any changes at this point. I'm just going to launch the cluster. So I'm going to do Kops update cluster and I'm going to specify yes. And again, I will specify the state. This will then launch the cluster. It will take a couple of minutes. and then I can try to run one of the examples. So now the cluster has been created, and let's have a look what this means. Road config for Kubernetes New Tech Academy in this file. I'm just going to get this file. And this is actually the certificates that we need and the password to log in to our new cluster. That's what Kops configured already for us. So for instance, we have here the server HTTPS API Kubernetes New Tech Academy, and that's what we will be able to use. Let's see if the nodes are up. So kubectl get node. 3 nodes in ready status, 1 master. This is going to be the master. It's in a different IP range, and then 2 nodes. Let's try to run the same deployment as we did on the Minikube cluster to test whether our Kubernetes cluster using Kops is working. So I'm going to do kubectl run hello minikube, which is the name of the deployment, and it's going to use this image, the Echo server version 1.4. And Echo server in this Docker container listens on port 8080, so we specify port 8080 as an argument. This is going to create the deployment hello minikube, and now we can also expose this service so that we can access it externally. We can do that using kubectl expose deployment, the name of the deployment, which is hello minikube, and we give it a type. This is the type of the service. For example, if you want a load balancer in front of this service, then we can say type load balancer, which I will cover in the next lecture. I'll do now a more simple version, just node port, which will expose a port on every node of this Kubernetes cluster that we can contact this service on. It is on every node except the master. So you can connect to every node on a specific port, but not on the master. So service hello minikube exposed. So if you now do kubectl get services, we see now our hello minikube service type node port, and this is the port that we can contact our service on. So this port is now open on every single node in our Kubernetes cluster except the master. Let's have a look at the AWS console. Let's first go to EC2. Make sure that you are in the correct region. I launched it in Ireland, so I'm in the Ireland region, and then you should see 3 running instances. So I have here 2 nodes and 1 master node. This one is terminated, so you can ignore this one. If you don't see your nodes, you can also have a look at the autoscaling group, which is here on the left. Autoscaling groups. You should have 2 autoscaling groups, one for the master and one for the nodes. And it's this autoscaling group that will launch the instances. So if something is wrong, for example, if you're reaching AWS limits, then it should be displayed here. Then for some reason, it couldn't launch an instance. But for us, everything went fine. We have 2 instances running. We exposed the node port, which means that those 2 nodes will reply on this port and redirect my traffic to this service. Before we can access it, we need to make sure that the firewall is not blocking us. So these nodes have also a firewall. They have a security group. And to see the security group, you just can click on the instance and then you can see the inbound and outbound rules. So here port 22 is open, but not the node port that we just created using this service. So we will need to make changes to this. So if I click on the security group, I go to inbound, I click edit, I can add a new rule. I can say custom TCP. I can copy paste a port that is exposed. So this was 30,032. I can paste this here, and you can either open it for everyone, 0000/0, or only for my IP address. I'm going to choose only my IP address, so only me will be able to access this service. I click save. I can go back to my node, and I can take the external IP address of this node or of this node. The IPv4 public IP address is listed here. I can copy this, and if I go to this IP address, port 30,032, I get the response from my service that I launched on my Kubernetes cluster. So this works. I have a running Kubernetes cluster. I have 2 normal nodes and 1 master node, and I created our first deployment, our first service, and I exposed a node port that I now can connect to using the IP addresses of any of those 2 nodes. In the next lecture, I will explain you a better approach using a load balancer that gives you also a host name, and then you can also use DNS to give your service a real DNS name, a real domain name. So once you did this demo and you are not using the cluster anymore, I would recommend you to remove the cluster. So I will show you how to do that. So to delete our cluster, we can do Kops delete cluster, then the name of the cluster, Kubernetes New Tech Academy, in my case, and then we can also add the state. So the state is an S3, and then it's going to show us what will be removed. We must specify yes to delete the cluster. So we're going to execute the same command using yes, and that will then bring the cluster down again. And the next time you want to use it again, you can just execute Kops create again, just like you did in the beginning of this lecture. So if you have any issues with bringing up this cluster, there's a troubleshooting lecture if you have DNS issues, or you can use a Q&A to ask me questions if you run into any problems. If everything went fine, just continue with the next lectures. This deleting of the cluster will take a couple of minutes, and then your cluster is removed. Now that you have your own cluster running, locally using Minikube, or on AWS using Kops, now I can show you how building containers works, so you can run your own containers on Kubernetes. So this lecture will be about building your own app in Docker. To build containers, you can use Docker Engine. You can download Docker Engine for Windows, Mac, and Linux. There are 3 different URLs. There are also different ways to set up Docker on your host system. All the installations are pretty easy. You just download the software, you install it, and you can use Docker. You can use that, or you can use my Vagrant DevOps box, which comes with Docker installed. On my GitHub, I have a DevOps box, which is a Vagrant box, which you can use, which will automatically install Docker for you. In the demos, I will always use an Ubuntu Xenial box set up with Vagrant. I showed you how to do this in the AWS preparation demos. If you haven't followed those, but you would like to run an Ubuntu Xenial box, then have a look at those demos. The DevOps box is also Ubuntu Xenial, and you can find the URL for this DevOps box in the procedure document. So whether you use a plain Ubuntu or the DevOps box, it's almost the same. Also, you don't have to use Vagrant. Docker is available for Windows, Mac, and for Linux. So you can use it with whatever operating system you want. Let's talk about Dockerizing a simple app. I'm going to show you how to Dockerize a Node.js app, but you can Dockerize any application you want. So Dockerizing a simple Node.js app only needs a few files. You need a Docker file. Every container you want to build needs a Docker file. Let's just go over the few lines that are in this Docker file. First line, from Node 4.6, we are saying our image is going to be based on the Node image. This Node image is publicly available. Docker will download version 4.6 from this official Node image. Our work directory is going to be /app. In this Linux environment that comes from Node, we are going to create the directory /app. And the current files in this current directory are going to be copied to /app. I will show you the other files in just a moment. It's just going to be the JavaScript files for this Node.js app that are going to be copied to this /app directory. To prepare this Docker image, we're going to execute some commands. You can do that using the run command. So this is going to run npm install. npm install is a command that will install all the dependencies so that we bundle the dependencies together with this Node image. So we will have the Node image with the Linux operating system and all the dependencies, and then we're going to add all dependencies that this app needs. It's going to expose a port, in this case, port 3000. And when this container itself starts, then it's going to run npm start. Let's have a look at the other files in this directory that will then be copied to this /app folder. The first one is index.js. A very simple Node.js app, only a few lines. It's going to load some of the dependencies that it needs to start a server. And then when it gets a hit on / the main page, it's just going to say hello world. This app is going to listen on port 3000. And when it starts, it's going to print to the console. The example app is listening at host and port. Then a Node.js app typically has a package.json file. And in this package.json file, we're going to define the dependencies. It's basically the metadata of this app. So our app has the name my app. It has a version. You can choose whatever version you want. It's a private app. We're not going to put it into a public repository. It has scripts. This is just going to define what happens if you do npm start. So if you take a look at the Docker file, we see npm start, well then node index.js will be executed. It depends on the engine, node 4.6.1, and it has one dependency. The dependency is Express. So when we do npm install, then it's going to install Express in the /app directory. So we have a /app directory with index.js, package.json, and npm install is going to run when we're going to build this Docker container. Is going to install the dependencies in /app. You will see this working when I do this in the shell. You just need to understand what these three files mean. The flow itself of building the image, you will clearly see when we're going to run the docker build command. So to build this project, docker build can be used. Docker build can be executed manually, or you can use CI/CD software like Jenkins to listen for any changes to your project and then automatically execute a build. We are going to do it manually for now. Later on, you can automate this easily. To build the Docker image from the previous line, this is what we're going to do. We're going to cd to the Docker demo. This Docker demo is also a Git repository on my GitHub. So you can clone this Git repository or you can download this as a zip file. Again, procedure document. You will see the URL as well in the next demo. Here you have then a Docker file, index.js and a package.json. If you want to build then this image using the definition in this Docker file, you enter docker build and that is going to start the build process. After the Docker build process, you have built an image that can run the Node.js app. And that build process that I just explained, that's what I'm going to show you in the next demo. In this demo, I will show you how to build your own Docker image. If you already followed my other training, Learn DevOps Continuously Deliver Better Software, then this will be very familiar and you can actually skip this lecture. In this demo, I'm going to use my Ubuntu Xenial Vagrant box. If you haven't set up one yet, have a look at the demo where I explain how to set up a cluster on AWS. The first demo explains you how to set up a Vagrant box with Linux. Like I said, you can also just download Docker for Windows or Docker for Mac and then execute the commands in a terminal or using CMD or PowerShell on Windows. I'm going to use Linux. You can get exactly the same box, so you should be able to exactly replicate this labs using this Vagrant box. First thing I'm going to do is I'm going to install Docker. I can do that using apt-get install. So I'm just going to apt-get install docker.io, which is going to install Docker for me. This is going to install the latest version that is bundled with Ubuntu. If you want the really latest version, then you will have to get the latest version from their website. And their website also has the instructions how to install the latest one. This one is bundled with Ubuntu version 1.12. Definitely good enough to do the lab. I'm also going to install Git. So apt-get install Git. In our case, it is all installed. Why do I need Git? I'm going to git clone my Git repository. So github.com docker demo. You can also just go to this URL and you can download a zip file. So you don't really need Git. It's just easy to clone it straight here. And then we have the directory docker demo. So in this directory we have the index.js, the package.json, and the Docker file I explained. You also have a Docker compose and an index database.js. You don't really have to take a look at that. Those are used in some of my other courses. I just have one Docker demo repository that I always reuse. Docker build is going to use the Docker file. So let's have another look at this Docker file. Looks exactly the same. So now we can execute the Docker build. You can execute Docker build as root with sudo. So you can do sudo docker build and then the current directory. Or you can make sure that the user Ubuntu has access to this Docker group. Because then user Ubuntu, our user, will always be able to execute Docker. And you need to do this as a root. Once you do this, you actually need to log out and log in again. So I'm just gonna exit here, do vagrant.sh again, go to Docker demo, and then now I can do the Docker build of this Docker demo. I just paused the video for a second, and this is what you should get. So Docker has successfully built this container. And if I go back to my Docker build, you can see first it pulled the node image, then it set the working directory to /app, added the files to /app, then runs npm install. So this gets all the dependencies for node, it installs it, it's quite a lot, and then it says npm info OK. It exposes port 3000. Make sure that when you start a container, it uses npm start. So then we have this container, and you could already run this container. You can use docker run -p port 3000 is the port that this app is running on, and we want to expose it as port 3000 on the host system. So this Ubuntu Xenial is the host system. And this -t runs a Docker image with this ID. You can also specify the I flag for the interactive mode, so that if you press Ctrl+C, it will actually get killed and you don't have to kill it manually afterwards. Just going to run this. Let's open another window. And I'm just going to do curl localhost 3000, and then we have the hello world. So this is the hello world of the index.js. So that's it. Next, I'm going to explain you how to get this image online on Docker Hub, so that Kubernetes can download this image so that we can run this image on our cluster. In this lecture, I'm going to talk about the Docker registry. I'm going to show you how to push containers to Docker Hub. You can run the Docker app by executing docker run locally. That's what I just showed you in the previous demo. Docker can be run locally for development purposes. If you just want to do some local development, you can run your containers locally. You don't need Kubernetes for that. To make an image available to Kubernetes, you need to push the image to a Docker registry, like Docker Hub. The first step will be to make an account on Docker Hub. Then you can push any locally built images to the Docker registry, where the Docker images can be stored in. To push an image to Docker Hub, you first need to use Docker login to log in with your user ID and your password. You then tag your image ID, the one that was outputted when you ran Docker build. You need to tag it with your login / Docker demo or any name that you want to give to your image. Then you can Docker push this image, and then your image will be uploaded to Docker Hub. Or to immediately tag an image during the build process, so you don't have to do it in 2 steps, you can go to Docker demo, do the Docker build again, and then use -t to immediately tag your build. And then you can also log in and push your Docker image to Docker Hub or to any other registry that you want to use. If you're not using anything yet, Docker Hub is the easiest. If you're using AWS, then AWS, for instance, has an alternative Docker ECR. I will be using Docker Hub, but feel free to use your own one. Just a few remarks. You can build and deploy any application you want using Docker and Kubernetes, if you just take into account a few limitations. You should only run one process in one container. Don't try to create one giant Docker image for your app, but split it up if necessary. All the data in the container is not preserved. When a container stops, all the changes within a container are lost. You can still preserve data using volumes, which is covered later in this course. For more tips, check out the 12-factor app methodology at 12factor.net. So there's a methodology on how to write stateless applications, which is a very interesting read. Have a look at this website if you're interested in that. Here are also a few official images you might want to use for your app. There is Nginx, which is a web server. You can use a PHP image. You can use a Node image, that's the one I used in the demo. You can use a Ruby image. You can use a Python image, or you can use a Java image. And there are many more that you can use to build your containers on hub.docker.com. In this demo, I'm going to show you how to push a Docker image to Docker Hub. I'm again logged into my Ubuntu Xenial box, and I'm going to use Docker login first. If you don't have a Docker ID yet, you have to go first to hub.docker.com. This is the website. If you are new to Docker, you can create your free Docker ID. You just have to enter your email address and a password, and then you can sign up. And then you can use those credentials to log in here. So I'm going to enter my username and my password, and then I'm logged in. Once logged in, you can create a new repository. Your repository is always going to be prefixed by your username, and then you can enter a name. For instance, you can say Docker Demo. Then you give it a short description, maybe a full description, and you can make it public or private. At the moment, you can only have a limited private repositories, but you can have unlimited public repositories. I already have a repository. My repository is Kubernetes Demo, and that is the repository that I'm going to use. Feel free to take any name that you want. So the next step is to tag our image, a previously created image, with the repository name that we specified in Docker Hub. So I'm going to use Kubernetes Demo. So I'm going to tag this image with this. If you don't remember your tag anymore, you can use Docker images, which is just going to list all the images of your system. Here is my Node image, for instance, and then you will see the image that you have created. I have this one now tagged. So this is my image, and my image is now tagged with the name. So I can now Docker push this image to my repository. So I'm going to push this to Docker.io, my name, Kubernetes Demo. This will take some time to upload, and then if you take another look at Docker Hub, you will see last pushed a few seconds ago. And then here, we didn't really specify a tag name. It has a tag name latest, and it is 256 megabyte. You can specify a tag name. If you don't, it just takes latest. So Docker tag with :latest is exactly the same as not doing it. So you can either tag it with latest, or you can give it a version ID. I'm not going to give it a version ID. I'm just going to use latest. So now everything is ready to use this image that we just pushed to Docker Hub, to use this in Kubernetes. So that will be the next step. In the next lecture, I will show you how to then run this image on Kubernetes. Now that we uploaded our image to Docker Hub, I will now explain to you how to run this app on Kubernetes. Let's run our newly built application on a new Kubernetes cluster. Before we can launch a container based on this image, we need to create a pod definition. A pod describes an application running on Kubernetes. A pod can contain one or more tightly coupled containers that make up the app. Those apps can easily communicate with each other using their local port numbers. So if you would have another app, you can just connect to that app on that port. Our app only has one container. To make this app running on your Kubernetes cluster, you create a pod file, for instance pod helloworld.yml with the pod definition. This .yml file is in YAML format. If you want to know more about the YAML format, then you can just look it up on Google. It starts with the API version, it's v1. This is a pod definition, so you say kind pod. You can provide metadata, you can give your pod a name. This pod is named node.helloworld.example.com. We can also give it a label. Later on we can easily filter on labels. This pod has the label app as a key, hello world as a value. In spec, you're going to put the container definitions. We only have one container, so we're going to give it a name. The name of this container is Kubernetes Demo, and the image refers to the image that we uploaded to Docker Hub. First your login, Ward Viana is my login, then slash, and then the repository name. The ports that you want to expose on this pod, here I'm going to expose container port 3000. You can use kubectl to create the pod on the Kubernetes cluster. You just use kubectl create -f and then the path to this YAML file. All these YAML files are bundled in another GitHub repository. The URL of that GitHub repository you can find in the procedure document again. Here are then some useful commands that you can use on pods. I will just briefly go over the list now, and then I will then show them in action during the demos. kubectl get pod gets information about all the running pods. So once you create a new pod, it's probably the first command that you're going to execute. kubectl describe pod, and then you can insert the pod name, describes just one pod. So this gives you more information. kubectl expose pod and then a pod name, and then a port and a name. This exposes a port of a pod, so it creates a new service, and then you can connect to your Kubernetes cluster on that port, and then it will redirect to your pod. kubectl port forward, and then a pod name, and then a port number. You can port forward the exposed pod port to your local machine, and then on your local machine you can go to that port, and then it will port forward to the pod. You can also attach a pod to see what is really happening in your pod. You can execute commands on the pod. So this then just executes a command in the container. If you have multiple containers, you can specify specific containers using -c. Otherwise, it will just take the first container. You can still label pods after they have been created. So if you want to add another label, then we can do it like this. And then this is very useful for debugging. You can run a shell in a pod, and then you're going to run kubectl. You're going to specify an image, and the image can be busybox. And busybox is a very small image that can start your shell. And when you have a shell, you can debug anything that goes wrong much easier, because then you are in a new pod and you can connect to your other pod that maybe is malfunctioning. In the next demo, I will then show you how to launch this pod. In this demo, I'm going to show you how to run your first app on Kubernetes using pods. First of all, you will need to clone my GitHub repository. So again, you can use the git clone command, or you can go to this website and you can download a zip file. So this repository is called Kubernetes course. On this machine, I have my Minikube cluster running, just as I explained in one of the previous demos. So I can immediately use kubectl. So kubectl get node is showing me that my Minikube is running. So I have here under first app, I have the hello world YAML file, and this file I'm going to use to create the pod. So I'm going to use kubectl create -f first app hello world.yml. Kubernetes came back to me. It said pod node hello world example.com created. So if I now use kubectl get pod, then you can see the pod that was previously running, which is a pod that I started when I installed this cluster, which is already running. And then I have another pod, node hello world example.com. So let's have a look at this one using describe pod and then the name. At the bottom you see the events, and you see one of the events is that it's now pulling the image. So it's pulling this image, needs to download the image, and then it will start the pod. So here I see some info about the container, my labels, status is pending. If you don't have a very fast internet connection, it can take some time to pull this image. So now it started the container with Docker ID and then the ID. Our pod is now running. There are now multiple ways to get to this pod. The first way is to use port forwarding. We can use kubectl to port forward, and then we just use the name of the pod. We can port forward the pod port, which is 3000, and we can listen locally on port 8081. So then I can locally, on this machine, connect to 8081, and then kubectl is going to make sure that all this traffic is redirected to port 3000. So this stays open. I just have to open a new shell, and I can just do curl localhost on 8081, and then I get the hello world. This is one way to quickly test whether it is working. The second way is to create a service. In the next lecture, I will explain you how to create a service for AWS. If you're running a cluster on AWS, that's going to be interesting for you. If you're using Minikube, you can just expose the port and then connect directly. You can do the same on your AWS cluster, but on AWS, you have the possibility to use a load balancer. So a load balancer is always going to be better for you. Let me first show you how to expose this port. We're going to use kubectl expose. We're going to expose a pod, and our pod name is node hello world example.com. And we are going to use type node port, which means that we can directly access port 3000 on Kubernetes, and it will redirect to this pod. And actually, in this case, we also need to provide a name for this service. So we'll just say node hello world service, because we cannot use this as a name for a service. So a service node hello world service exposed. Now we just need to know the IP address of the Kubernetes cluster to connect to. If you're on AWS, you can just use your master node. You will have to change your security groups though. If you're on Minikube service, this node hello world service -- URL. And this gives us the correct mapping. So this port forwards to port 3000. So if we do kubectl get service, we see the newly created service that exposes port 3000. With Minikube, we can use this port to connect to this service, because this is an IP address that I can use from my host system, from my Mac. These IP addresses here are IP addresses within our cluster. So those are two different things. So I'm going to use my browser, and hello world, it is working. This demo is really a continuation of the previous demo. It just became too long, so I split it up. In this demo, I'm going to show you some useful kubectl commands. Some more commands I can use: kubectl attach, and then the pod name. This attaches to our running process, but our process is just running, so we're not going to see much here. If our process would output some log, we would see the logs here. We can also execute something in that container. So we can use kubectl exec to execute a command. So let's say that we use ls-app. That's what is in our /app folder. So this is a list of the files of /app in the running container. If you would create a file here using touch, for instance, app test.txt, this test.txt will disappear if this container is killed. That's what I meant earlier with the data of a container is never persisted. It just disappears when the container is stopped. You need to use volumes, which we will see much later, if you want data to be persisted over time. There's still one command that I want to show you. I first want to show you the service. So I'm going to do describe node hello world service, describe service, node hello world service. So it has a label. We expose it as a node port. It has an IP address. So this is an endpoint that is exposed that we could connect to from another pod. You can either use this endpoint or we could use the node port, because the node port is a static port that will be always accessible. I'm going to use this endpoint now. So I'm just going to copy paste this. And what we're going to do is we're going to launch another pod with busybox. So we're going to use image busybox and we're going to execute a shell. And this is going to create a new pod with a new container. And then we can just execute commands on our Kubernetes cluster. I don't have curl here. So what I'm going to do, I'm just going to telnet to this endpoint of my node hello world service. And then I'm going to say get slash. I get a 200 OK back. And this is my express server. So it says hello world. So this is another way of connecting to the pod from within a cluster, not within the same pod, because then I could actually just connect to localhost port 3000 if it was a container in the same pod. This is another pod, and then I can use this endpoint and connect to this pod still. Later on I will talk about service discovery and DNS, and we're not going to use these manual endpoints, but for now I just want to show you what is possible. In the next lecture I will show you how to expose a service that uses the load balancer on AWS. In this lecture I will show you how to set up a load balancer for your first app. In a real world scenario, you need to be able to access the app from outside the cluster. On AWS, you could easily add an external load balancer. This AWS load balancer will route the traffic to the correct pod in Kubernetes. There are other solutions for other cloud providers that don't have a load balancer. Like you can run your own HA proxy or Nginx load balancer in front of your cluster. Or you can expose ports directly. In this lecture, I will show you how to do it with AWS. The first app that we launched, you can see the YAML file on the left. It is just going to run the pod with the Kubernetes demo, which just returns hello world on port 3000. This is the pod definition. On the right, we have the service definition, and the service definition is going to put a load balancer in front of our pod so that our pod can be accessed from the internet. This service has type load balancer, and when you specify this type load balancer on AWS, it will start an AWS ELB, an elastic load balancer, which is a service that Amazon provides. This service is defined in a YAML file, but earlier when we were using Minikube, then we were using the command kubectl expose, and that also creates a service. We just don't define it in a YAML file. Here we define our service in a YAML file and then submit it to the cluster. It's basically the same thing. Whatever you do with kubectl, you can also put in YAML files. So this YAML file is of kind service. It has a name, hello world service, and it also has a spec. I will go over the spec in detail in the demo. For now, just remember that you can have different services. This service is of type load balancer and will run an ELB. If you run this pod and this service, you could then point a host name like example.com to the ELB to reach your pod from the internet. So this is the way to make your application available to the internet. I will show you all the details in the next demo. In this demo, I'll be running the first app behind a load balancer. I'm again going to log into my Vagrant box, the same one I used to spin up my AWS Kubernetes cluster with Kops. I have the Kubernetes course cloned right here. If you haven't downloaded the course material from GitHub yet, have a look at the procedure document. So here I have two files that I want to use. The first one is our hello world, the pod, and I added here the name. So it's still running on port 3000. I just added a name Node.js port, which I can then reuse in the service. So our service is going to be of type load balancer, which in our case is going to be an elastic load balancer on AWS. It will be automatically created for us. Port is going to be 80, the standard HTTP port, and the target port is going to be the Node.js port. Then Kubernetes knows that it needs to go to this container. Protocol is TCP. The selector is going to refer to our app. So we have app hello world. It's going to be the service for the pod with the label app hello world. I'm going to run this. kubectl create -f of the pod and then of the service. So this takes some time. While this is setting up, let's have a look in the AWS console. So I'm here on the main page and I go to EC2 and we have now one load balancer running. So this load balancer is internet facing. It's running on port 80 and it's going to refer to our 3 instances. Those 3 instances will route the traffic to our pod. That's why ELB adds all 3 of them. The ELB doesn't know exactly where the pod is running, so it just adds all 3 of them, and every node will then redirect the traffic to where the pod is, because the nodes know where the pod is. So there's a health check on this port. So this is a node port that is exposed on every node, and that will be the port that is used by the ELB. So the mapping is from port 80 on the ELB itself, and it goes to the instance port 32162 to the node itself. And then on the node, it will redirect the traffic to the correct pod. This ELB has a DNS name. So what we can actually do is, if you go to root 53, this is our hosted record for the Kubernetes zone, I can create a new record and I can say hello world.kubernetes new tech academy, and I can say this is an alias for our load balancer. So I can create this and then I can actually use this to directly go to the load balancer and directly to my app. If we go to hello world Kubernetes new tech academy, you can see hello world. So our root 53 hello world Kubernetes new tech academy goes to our load balancer. Our load balancer redirects the traffic from port 80 to one of those 3 nodes on this instance port, and then the traffic is redirected to our pod, which then gives hello world. If you would go to the security groups, you would also see that we have a new security group for our load balancer, which is right here, our ELB. And then if we go to the nodes or even the master, you see that this one ends with 2A. We have all traffic open between our Kubernetes nodes and the load balancer, so that the load balancer can access our Kubernetes cluster. So that's it for this demo. Now we can actually create apps on Kubernetes that you can expose to the internet using the elastic load balancer of Amazon. This is the end of the section Introduction to Kubernetes. Let me recap this section using a few diagrams to make sure you understood the concepts. I showed you how to deploy a first application to the Kubernetes cluster. First, I showed you how to create a container image using the Docker command line. So we created locally an image, we tagged it, and then we uploaded the container image using the Docker push command to Docker Hub. So at this point, Docker Hub has a container image called Kubernetes example. Next, I created a first pod, Kubernetes example, and this is the definition of this first pod. What is important here is that we defined a container. We can define one or more containers in a pod that will run on the Kubernetes cluster. This container image uses the port 3000. That's why I defined a port with the name Node.js port, and the container port to contact the server is port 3000. This launched our first pod on the Kubernetes cluster. We used the command kubectl create to send this YAML file to the Kubernetes cluster, and Kubernetes launched this pod. What Kubernetes is going to do then is going to pull the image from Docker Hub, because we defined that image in the YAML file. So it pulls this container image and it starts running the container in this pod in Kubernetes. Next, we want to contact the pod. And because we don't have a service yet, we need to use another way to contact it. One way that you can use to contact a pod from your local machine is using port forward. So using kubectl port forward, and the name of the pod, and then the ports that you want to use. The first port is a local port on your machine that you want to open, and the second port is the port of the pod, in this case 3000. Once we enter this command, we can use our browser on our local machine or a curl command to contact our pod, and we can do that on port 8081. Port forward is not the regular way that you would contact an app. It's just a way for us to contact the app locally because we are administrators of our Kubernetes cluster. The real way to contact a pod is to create a service. So that's what we did next. We created a service. We defined the YAML definitions and we used kubectl create to create the service on the Kubernetes cluster. This, for example, is a YAML definition for a service for the Hello World service that is of type LoadBalancer. If you are on the cloud, on AWS, on Google, on Azure, you can use type LoadBalancer to put a load balancer in front of your service. So this will launch, this will spin up a load balancer on AWS, and then you can contact this load balancer on port 80, because port 80 is defined here, which is a standard HTTP port, on the load balancer host to contact your app. This is a normal way to contact your app, because then you expose your app to the internet, everyone can contact it. Load balancer is not the only way to expose a service. There's also another way to expose a service using a node port, which will just open a port that you define, or when you don't define a node port, it will choose a random port, and it will open that port on every single node of your cluster, except the master node. So that way it doesn't create a load balancer, but it opens a port on your Kubernetes cluster nodes so that you can contact your app. This can be useful, for example, if you're going to deploy on-prem, where you don't have a load balancer, then you can use a node port. There are different ways to contact your app, and you will see in the next lectures, in the next sections, different ways that you can contact your app. These are just two ways that I just showed you. Now you might ask yourself, why do we need this service, and why don't we just contact the pod directly? Why can we not just put a load balancer in front of a pod? Well, now we have only one pod, but you might have more than one pod. We might have 5 pods. So the service that we create makes sure that we then load balance the requests over the multiple nodes in case that we have multiple nodes. In Kubernetes, we'll always have pods and we'll always put services in front of them. And from outside, we'll always contact the service first, and the service will make sure that your requests are routed to one of the pods that you are running. Let's say that your pod is malfunctioning. Pod 1 is malfunctioning. There are ways that you can use to debug the problem. First of all, you can use kubectl attach to attach to the pod to see what is happening. You can maybe see some output that will help you debug your problem. You can execute a command. For example, if you execute the command bash or sh, it will open a shell, and then you can type more commands to debug your problem. Or you can also use kubectl logs to show you the logs of the pod. Maybe there is something in the logs that can help you. So these commands are very helpful to debug issues with your pod. Then there's another possibility. You can also launch a new pod. For example, you can use kubectl run to launch a pod busybox that is using the image busybox to then pull the image busybox from Docker Hub and launch it in a pod. You will then execute the command sh in that pod, and then that will then open a shell, and that allows you to execute more commands to debug the problem. You could, for instance, connect from this busybox pod to the Kubernetes example. So that's it for the recap. I hope I made it a little bit more clear what we try to achieve in the first lectures. In the next lectures, I'll go into more details on how you deploy applications on Kubernetes and how the architecture of Kubernetes really looks like.